All right, quantitative literacy. This is the second video for 11.3 notes. We've got some kind of funky word problems here. For the first one, we're talking about me throwing strikes or balls. First thing is my unconditional probability of throwing a strike is 0.6. So basically saying if I don't know anything else, if I walk out to the pitcher's mound, I've got about a 60% chance of throwing a strike. But if I threw a strike, I get more confident and I move up to an 85% chance of throwing a strike after I've already thrown one. On the other side, my confidence goes down if I had just thrown a ball. So the probability of throwing a strike after a ball is only about 30% or 0.3. So on letter A, what's the probability of me throwing strikes on 3 randomly selected pitches? Now, these are going to be multiple events, so we're going to multiply the probabilities together. Here's how I want to think of this. I've got my first pitch, my second pitch, and my third pitch. And I'm going to figure out what each one of their probabilities is, and I'm going to multiply these together. So on the first pitch, I don't know what happened before. So my probability of throwing a strike, actually I should put this on here. These should all be strikes. So first strike, second strike, third strike. The first strike has a 0.6 chance, or first pitch, excuse me, has a 0.6 chance of being a strike. But now for the second pitch, my confidence went up. So now I have an 85% chance of throwing a strike here. Then my third pitch, the previous pitch was a strike, again has an 85% chance of being a strike. I multiply all these together, which you just do on your calculator, and I would have a 0.4335 chance, or about a 43% chance-ish. So I have a little less than a 50-50 chance of walking out to the mound and throwing 3 strikes in a row, according to all this data. On the second one, throwing 2 strikes and then a ball. The last pitch to the previous batter is unknown. Okay, so 2 strikes. So first pitch, strike. Second pitch, strike. Third pitch, ball. I'm going to figure out each one of these, and I'm going to multiply them together. The first pitch, strike, that's still back to the unconditional probability. There's a 0.6 chance. Just like I did on the previous problem, that previous pitch was a strike, so now my confidence goes up, and I have a 0.85 chance of throwing a strike here. Now, for the third pitch, this is where things get really funky. I threw a strike previously. That means there was an 85% chance that this third pitch was a strike. If there was an 85% chance of a strike, that's a 5, that means that there's only a 15% chance of a ball. So what I'm actually doing here is saying that there's a 1 minus 0.85 chance of throwing a ball if I threw a strike previously. What a lot of you will probably think is, oh, shouldn't I be using that 30%? That's only the chances of throwing a strike after throwing a ball. But again, the previous event was a strike. So that means there's an 85% chance of a strike, which the only other option is a ball. There's only a 15% chance there. So I'm actually multiplying 0.6 times 0.85 times 0.15, which will give me 0.0765. For letter C, and actually let me erase some stuff here, move some stuff up here so I can got room. So throwing a strike and then a ball. All right, so first pitch, strike, second pitch, ball, after walking the previous batter. So walking the previous batter means that the last pitch I threw was a ball. So now I do have info. So I'm not going to use the unconditional probability. I know what happened previously. I threw a ball. What are the chances? So even though it's not calculated in here, the previous pitch was a ball. What are the chances of throwing a strike after throwing a ball? That's only 0.3. The second part, look at the previous pitch. The previous pitch was a strike. There was an 85% chance of throwing another strike. So just like we did on the last problem, there's a 1 minus 0.85 chance of throwing a ball. So on this problem, I'm multiplying 0.3 times 0.15, which will give me about 0.045. On number 6, now we're looking at some basketball, and we're talking about Shaq. Shaq was notorious for not being good at making free throws. He only was a 53% free throw shooter for his career. First thing, a little bit of background here. A 1-and-1 means that I get up to 2 free throw shots. If you miss the first shot, you're done. You don't get to try again. But if you make the first shot, you do get a point on the free throw, and you get a chance for a second shot to get the second point. So a 1-and-1 means you're either going to shoot once or you're going to shoot twice. You're only going to shoot twice if you made the first shot. So now, fortunately, on this problem, we don't have to worry about if he makes a shot, his confidence goes up or anything like that. We're just using the 53% or 0.53. So the probability that Shaq scores no points, well, the only way that can happen is if he misses the first shot. So basically, this is not multiple events. This is just a miss. So there's only one shot, and it's a miss. Well, the chances of him making the shot are 0.53. So the chances of him missing are 1 minus 0.53, which is 0.47. The chances of Shaq scoring 1 point. Well, this is going to be a multiple event thing. This means that he makes first shot, but then he misses the second. So this is 2 events. Event shot 1 is a make. Shot 2 is a miss. So the probability of making the first shot is 0.53. The probability of missing the second shot, well, we just did that on the previous problem. The chances of missing a shot for him is 0.47. So we're going to multiply those together, and that will give me 0.2491. And for the last possibility, Shaq scores 2 points. This means that he makes the first, try that again. Shaq makes the first and second shots. So first shot is a make. Second shot is a make. So Shaq has a 0.53 chance of making the first shot. He also has a 0.53 chance of making the second shot. I'm going to multiply those together, and that will give me 0.280009. That's a 0 in there. Oh, pen's not working very well. Let's try that again. 0.2809. There we go. One last thing that's kind of interesting about this problem, this covers all the possibilities, making no points, 1 point, or 2 points. Since all possibilities are covered, if you were to add all those together, it adds to equal 1, meaning it covers all the possibilities. Okay, that does it for the 11.3 notes.